Crich.
This is Devon.
Devon Watford. I was a student of his back in 2016-17, and now we're here to fly him, which is pretty exciting. Promise to bring him back in one piece. So here's our airplane, a beautiful airplane. This is an Icarus C-42. If anyone knows the tale of Icarus, it's a Greek god who flew too close to the sun and his wax feathers melted off. You hear about that?
No,
it's a Greek tale.
Known it, yeah.
That's where the name came from. It's a German airplane, that's why it's spelled with a K. And C-42 is the model. So just around here, obviously we have our wings. These create the lift for the airplane, and they do it in a couple different ways. First off, we have Newton's law. I've forgotten which number it is. I believe it's number 3, which is every action has an equal opposite reaction. It's number 3?
Yeah.
Awesome. That is because this wing is going to push air downwards. In the back, when we tilt up, it will push air downwards, and we will actually climb up because of that. And secondly, we have, I think it's Bernoulli's principle, or it would be Bernoulli's, I believe. And that is that you have faster, no, it's Venturi's effect. You have faster air on the top of the wing and slower air on the bottom of the wing. That's because we have, if you look at this side, we have more area on the top of the wing to cover than the bottom of the wing. The bottom is flat, the top has a camber to it.
Yeah.
And that means that the air has to go faster on the top to meet the air in the back.
Yeah.
Because of that, faster air means lower pressure.
Right.
So if we have a low pressure zone on the top of the wing and a high pressure zone on the bottom of the wing, up. Those are the two primary principles that we get to make lift on an airplane.
Yeah.
Angle of attack, which is the angle from which this wing meets the relative airflow, which is coming towards it, will dictate how much lift we get versus how much drag we get. Primarily, we are using Venturi's effect, which is the faster air on the top of the wing.
Yeah.
When we're at high angles of attack, we will get the Newton's third law primarily.
Right.
That's the beginning of this. Moving forward, these guys are our lift struts. So these primarily take on positive load. When the airplane is being pulled backwards, the wing wants to go upwards, and these will hold the wing in place. These are compression struts, and these primarily take on negative G load. So if the wing was to be pushed downwards, these will prevent the wing from crowding in on itself. That's what the purpose of these guys are. Moving backwards, the tail. This controls our longitudinal axis and allows us to move up longitudinal axis, which would be the pitch axis. And this goes pretty much over Newton's third law. So every action has an opposite and equal reaction. When I push this up, wind goes up, tail goes down, nose goes up, down, other direction. Wind goes down, tail goes up, nose goes down. Rudder is the exact same principle being used. This controls our direction about the longitudinal axis once again, rotation about the normal axis, which is the axis going straight down through the airplane, allows us to rotate upon that. Awesome. These guys control the lift and stabilize the elevator, as it's called.
Right. All aluminum.
Yes, these are just stability rods so they don't flip on itself when you're pulling high using the airplane. Moving forward, that's about it for the physics portion of this airplane. Obviously, we have our battery here and our sight blaster here. These are our flaps. So if I was to deploy these flaps, they come down. That does increase the span of the wing as it makes it go longer, so we do get more of that Venturi's effect, but mostly this is pushing more air down. So we're allowed to fly at a slower speed, and we have more air going down, so more of the third law pushing us back up.
Right.
Awesome. The ailerons work in the same way. Pushed up brings that wing down. Pushed down brings that wing up. Pretty simple.
Yeah.
These wings are very, very, very strong, and the airplane itself is very, very, very light. I can demonstrate that. Doing that. See.
Could you do that again? Sorry, I missed that with the camera. Could you do that again?
Sure.
I missed that with the camera.
650 pound weight airplane.
Yeah.
And that demonstrates just how light it is.
Yeah. So the whole plane is 650 pounds?
Empty, yes.
Wow.
Empty. When I put fuel in it, it goes up.
Yeah.
Total about 740 with fuel in it.
Yeah.
And the passengers, obviously, that climbs all the way up to about 1,200 pounds before I can't fly anymore.
Yeah.
Legally, but physically it would continue to fly far past that, in my opinion.
Yeah, just the safety factor. Oh, true.
And that's how heavy my engine is. This is the heaviest part of the airplane. Obviously not very challenging to carry it.
So what kind, how many horsepower engine?
This is an 80, which sounds small, but if you consider that your average car is about 4,000 pounds, and consider this is 600 pounds, and your average car is about 150 to 200 horsepower,
Right.
that power to weight ratio is actually quite high in comparison to the car.
Yeah.
So it accelerates quite a bit faster than the car does. and it's quite a bit higher performance than a car is. It's just very light. So 80 horsepower is actually quite a lot for this engine.
Yeah.
It would still fly comfortably in our 40 horsepower. I had a plane that was a 23 horsepower engine. I bought it, and that would fly. To finish off the physics brief, this propeller works under the same principles as the wing does. It's just a wing right here that is rotating, and this works off of Newton's third law again. This guy pushes air backwards, and it does it at a large amount of air moving at a slow amount. And a jet engine would be the opposite of that. A jet engine pushes a small amount of air at a very fast speed. So being that we have a large amount of air at a small amount, we can go relatively slow, but we have high performance from a takeoff standpoint. Whereas a jet engine needs more performance the faster you go. So this is more applicable to our standards right now. That's why we use a propeller here. This pushes air backwards, which of course, we have the high pressure here, low pressure here, sucks us forward. And of course, because we're moving an air body backwards, Newton's third law would say that we are going to move forward with it.
Right. Air pushes you.
That's about that. If you want to see the inside of the airplane in the video, I can show you that too.
Sure. Here, you come through this way. Take a look on the other side.
This is a relatively simplistic interior for an aircraft. We carry the instruments that we need for what we want to fly. It depends on what type of flight scheme we are looking for, right? So in the bigger airplanes that I'm flying, we have more instruments for IFR readings, for navigation, for flying at different heights. Whatever you need, you're going to have instruments for. And these ones, it's relatively basic because we fly at daytime only, and only in VFR conditions with reference to the ground.
Right.
So for that, we need to have our airspeed indicator. This runs off of our pitot 2, which is over there.
Yeah.
Big red one right there.
Oh yeah.
Then we have our altimeter, which runs off of static air pressure. There's a port on the back of the airplane. And all that does is measure what the pressure is outside. No ram air intake on that one, just pressure outside. Lower the pressure, the higher this will read.
Right.
Very simple because air goes down in pressure at a consistent rate going up.
Yeah.
Super simple. This guy measures the difference in that pressure and the speed that we are changing that pressure. This is our vertical speed indicator. That's how that works.
Okay.
Tachometer, trim indicator. So if I want to move my trim, you can hear it select your motor on this one. And this would be our slip and skid indicator. That is just gravity. So I want to fly the plane so that you feel like you are centered at all times. How would I know that? Well, a level ball. If that's in the middle, then you must feel like you're in the middle too.
Yep, exactly.
And because we have 3 axes, we are not skidding turns like you do in a car all day long.
Yeah.
When I do a steep turn, you just feel heavy, but you don't feel like you're leaning side to side.
Right, yeah.
Moving forward, this is our radio column here, radium stack. This is our radio transponder. This works off of us sending a signal out. Tower to receive that signal, and we send them what our height is, direction, and our speed. And that way the tower can manage us. They do have a radar themselves, but does not send them our exact speed and does not send them to our exact height. So the better option is to use a transponder, which sends off a code.
Right.
Rather than just being bounced off the airplane.
Yeah.
It's more accurate.
Yeah.
Moving
And
forward.
then where's your tower? Who is your tower?
Here, no one. Farther out, there's lots of towers.
Yeah.
Depends where you go.
And the panic button is a nice touch.
Doesn't do anything. So we're not allowed to panic in airplanes. Well-known fact. Panic means that you're so scared you can't focus anymore. And as a pilot, we're not allowed to do that. And passengers, I'm not allowed to let it happen.
Yeah.
Because if you can't focus, then you're not safe anymore.
Yeah.
So panicking is not allowed to happen. This is our control stick. These controls are ailerons, which controls movement about the longitudinal axis, which means rotating about it.
Yeah.
Of course, longitudinal axis goes nose to tail, so rotating upon that would be roll.
Yeah.
Movement on would be this.
Yeah.
Movement about would be this. This is how Transport Canada says it.
And it's all in one stick.
Right, and then this is our pitch axis, which controls movement about the lateral axis because it's rotating about wing to wing. Right. And then our rudder controls our movement about the normal axis, which goes from the top of the airplane to the bottom, and that's how we control that. It also connects to the nose wheel for taxiing on the ground. Not gas and brake.
Yeah.
Gas is here, brake is here.
Oh.
These are engine gauges right here. So these make sure that my engine is healthy while I'm flying. If there's any indication of a problem coming, it will be demonstrated first in that. If I have an oil pressure problem, I will see that in about 5 minutes until my engine actually has problems.
Oh, okay.
An engine can run for about 5 minutes or so once it's losing oil pressure.
Yeah.
So if I have an oil leak, I will see my oil pressure decreasing, my oil temperature increasing. And the reason we have 2 different gauges is if one gauge was to fail, let's say my oil pressure just dropped to 0.
Right.
But my oil temperature was to remain at normal and didn't increase, then I'm assuming my gauge failed.
Yeah.
Whereas if I was to see that drop to 0 and my temperature increase, then I know that my engine's about to fail because there actually is that oil. That oil is now heating up extremely fast, and I'm going to reduce power and try and fill up the land as soon as possible.
Right.
That's about it.
Huh.
That's the basic demonstration of this aircraft. Of course, the bigger the airplane and the more capable it is, the more gauges there are.
Yeah.
And God, there's a lot of gauges.
Oh, I believe
Do you have any words you want to pass on to Mr. Crich's future students?
Of course, this is a super exciting industry. There's nothing better than this, honestly. When I come to work every day and fly airplanes, it's hard to not smile. It really is, and it's not something you want to ever call in sick to work on. Not because you can't, but because why would you? And when you have a job like that, it's so exciting. So I just recommend you guys really find your passion. You can find it early, and don't be scared by your age. I started this when I was 13 years old. I flew this plane alone when I was 14 years old. This exact plane right here, and it's never too early, never too late. As long as you're over 14 years old, you can start flying these guys. Even 13, you can solo at 14. And I just recommend that you find the job that you enjoy, and you'll work hard on it. It does not work. I study at home for 2 hours almost every night right now for my CPL, a commercial pilot license, and it's not hard to do it all. It's super interesting.
Yeah.
And when you find that subject you like, the studying part is nothing. Going to post-secondary to find a subject you really like is nothing. It's not hard work at all. Studying in high school, sometimes there's material you don't like, but you have to learn it just so that you're acquainted in the world. But if you want to, if you find something you like, there's no work involved.
Got her made, yeah.
That's it. And you will work hard and you'll succeed in it, so long as it's something you're interested in. And never think that it's too extreme to be interested in. You want to be an astronaut? Do it. You want to be a pilot? I did it at 14 years old. My mom didn't pay for it. I got a job and paid for it. And I had best year.
That's true.
It wasn't that hard. I loved it so much I would still make it happen. So
Yeah.
my motivation piece is do what you love and don't let anyone else tell you no.
Yeah, fantastic. Thanks, Devon.
Okay.
Yeah.